minus 4. So the first step is just recognizing this is a linear equation. And then the second step is to decide if your line is going to be dotted or solid. This says strictly less than 2/3 x minus 4. So when it's a less than symbol or a greater than symbol, you use dotted. And when it's less than or equal to or greater than or equal to, you use solid. So I'm going to use a dotted line on this graph. Basically, this means that the line is part of the solution region. Dotted means that the line is not part of the solution region. Like you don't have $10. You can't spend $10. You have to spend less than $10. So you have a dotted line. Then you graph your line. So that's what your quiz was just on, both quizzes. So I would start at a y-intercept of -4, and I'm going to go up 2 over 3. I'll do a couple dots. Now I'm going to connect it with a ruler, but I'm going to use a dotted line when I draw that line. So dot, 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 or dashed line. Okay, then step 4, now I have to figure out if I'm going to shade kind of this triangular region that's above or the triangular region that's below. So there's 2 ways you can figure out where to shade. I just like to read the inequality out loud. Y is less than 2/3 x minus 4. So if y is less than, where are the y values smaller than the purple line? Below it, right? These are the y values that are smaller. These are the y values that are bigger. So I'm going to shade below. It says you could test a point. So for example, if I test the point 0, 0, and I plug 0 in for x and y, I would get that 0 is smaller than -4, and that's not true. So 0, 0 does not work. So I'm going to shade the region that does not include 0, 0. I just like to read it out loud to myself, and it says y is less than my line. So this whole region, any point that I pick in that region, if I plugged it in, it would make that inequality true. So for example, you don't have to write this down. This is the point 10, 0. If I plug in the point 10, 0, it's going to make that equation true. So is 0 less than 2/3 times 10 minus 4? Yeah, because 2/3 of 10 is like 6 or 7. I don't know what 2/3 of 10 is. But then minus 4 is a positive number, and that is bigger than 0. So that point satisfies that inequality. So you can test a point and make sure it works. Has anybody graphed these before in Algebra 1B? Some of you have seen them before where you shade the region. Maybe it's new. Okay, next one. This time I've got a new inequality, and it's ready to be written in slope-intercept form. Y equals x plus 1. And should I do a dotted or solid line this time? A solid line, because it says y is greater than or equal to x plus 1. So I'm going to use a solid line, and I'm going to actually graph this equation, just like I did on the quiz. So what's my slope? My slope I can sneak in here is 1 over 1, right? I have 1x. So I'm starting at 1 on the y-axis, up 1 over 1. And this time I'm going to draw a solid line to connect the dots. So that means that any of these points that lie on the line itself will make this inequality true because it says y is equal to this number. So any of these points will work. And where do you think you want to shade? This inequality says y is greater than x plus 1. So where are the y values bigger? Up here, right? Does that make sense? Is that what you're going to say, Rishi? Okay. So I'm going to shade above. This whole region is the solution to this inequality. Yeah, sure. I need 2 for the next page. Because the system of inequalities is on the next page, right? We're going to graph 2 and figure out where the region overlaps each other. So this fits right in with graphing lines. The only further step is, should it be dotted or solid, and do I shade above or below? All right. And we're going to do practice on this tomorrow. So I think you have 2 more homework assignments. I think your last, what does it even say on here? Homework 1-7 was supposed to be due on Thursday, but that'll be due on Friday. So, oh, we haven't done 1-6 yet. We're kind of behind. Tonight I will leave as no homework, unless you want to start. So we'll say that homework 1.7, I'm actually going to reverse the order. This isn't 1-7 inequalities, does it say? 1-7 is inequalities. So homework 1-7 is due Friday, and homework 1.6 will be due Tuesday, because that's practicing for your test with some word problems. And that way, if you guys need time tonight to catch up on another assignment. All right, so here's graphing a system. What does a system mean? A system means, yeah, 2 or more. There's more than one. So see how I have more than one here? So step 1, graph each inequality individually. Step 2, indicate the feasible region. So that's the intersection of wherever your colors are going to overlap. I wrote this note here. When converting inequalities into slope-intercept form, if you multiply or divide by a negative number, be sure to change the inequality sign. Have you guys ever done that before? Like if you write over here in the notes, like if you had negative 4x is less than 8, do you know how to solve this inequality? It's just like solving an equation. What would you do to both sides to solve for x? Okay, but you said the magic word. You said I divide by -4. So when you divide by a negative, you actually have to flip the inequality symbol around, and x is greater than -2. So in an inequality situation only, if you divide by a negative number, it flips the inequality symbol around. If you don't have a negative number, let's just say you have 2x is less than or equal to 10. How would I solve this inequality for x? All right, divide by 2. I didn't say divide by a negative. So this would just be x is less than or equal to 5. The inequality stayed the same. So you only flip the sign when you divide by a negative. People haven't really solved inequalities, though. You should have looked at this a little bit, maybe in pre-algebra, solving inequalities, but you haven't probably used it since then. So kind of throwing in background information of algebra. Okay, so I'm going to graph these 2 lines. Remember, I like to write it in slope-intercept form. So y equals x is my equation. What's the slope of that line? If it's y equals x, the slope is +1, and the y-intercept is really 0. I can always write a y-intercept of 0. So I'm going to graph, should this be solid or dotted? Strictly less than, so dotted. This other one is going to end up being solid. How do I graph that line? So I start at 0 on the y-axis, and I go up 1 over 1, and I'm just going to extend it all the way across the whole graph. Dotted all the way across the whole graph. Okay, should I shade above or below this line? So if I read this inequality, which one is bigger, y or x? X is bigger. This says y is smaller than the function. So where are my y values smaller? Down here on the y-axis. I'm just going to circle this inequality in orange just so I can show that like this one is shading down here in orange. Don't shade it too dark because you're going to have to graph another line on your same set of axes here. So now I have to graph the second line and see where they intersect each other, or the second inequality, I should say. How can I get that solved for y? What should I do first to solve that for y? I should divide by 2 on both sides of the inequality, and I don't need to flip the sign around, right? Y is just greater than or equal to 3. So y equals 3 is my equation. What kind of special line is that? It should be horizontal. When it's a y equals line, it's horizontal. Should I do it? And I said I already said this. I'm going to do a solid line because it's greater than or equal to. So I'm going to do a solid horizontal line at y equals 3. Kind of like that. And I need to figure out, now I'm only looking at that horizontal line, should I shade above that or below that? So if I read this inequality, it says my y values are greater than or equal to 3. So I need to shade above the horizontal line. And there's one region over here that's already orange. I'm going to shade mine in like this purple or blue color. So I will have one region that is both orange and blue on top of each other. And that's called the feasible region. So somehow on your notes, indicate that that's called the feasible region. The other thing, some people are neat mix, and they like to graph their inequalities differently than how I do. So what they'll do is they won't graph anything until the end, and then they will only shade in their feasible region. So you can graph in 2 different colors and show the overlap, or you can shade nowhere except the feasible region. It's up to you. So if you want to erase everything except the feasible region, that's another way you'll see it on like the SAT or something. So I'm going to kind of go like this and say that that is the feasible region or solution region, however you want to call it. But on the test, it'll say in the directions, make sure to indicate the feasible region. And if you have no idea what feasible means, it just means the solution. Did we get there on that one? Kind of makes sense? So you're going to get better at graphing because we're going to be practicing graphing with these inequalities. All right, so number two, the first line is ready for me to graph because it's y equals 4x minus 1. Should this one be dotted or solid? Should be dotted. Did you finish that? Oh, thank you. So I'm going to go to -1 on the y-axis, and I'm going to go up 4, 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. What did I say this was? Dotted. So when I connect them, I'm just going to leave it like a dotted line. That's why I like doing it with a ruler, because it makes it a little bit easier to graph. So there's like 6 steps on a problem like this, right? You have to rewrite it as an equation, dot the line, shade it, and then do the same for the other graph. Should I shade above or below on this one? It says y is less than. So less than, sometimes it's hard when you have a really vertical line. Just remember these y values down here are smaller than these y values up here. So this is still kind of shading below the line. It's more like you're shading to the right. But if you look at the y-axis, this is the lower section of the y-axis, and that's what we care about. All right, what do I have to do on the second equation? Divide through by 2. And I don't have to change the sign. Y is greater than 4x plus 3. Do you notice anything about these two equations? They have the same slope. So let's see how that affects our graph. We are going to do a dotted line again, right? Because it says y is strictly greater than. So I'm going to go to 3 on the y-axis and go up 1, 2, 3, 4 over 1. When you draw this, try to make it look parallel to the other line. So when you graph your lines, they should not be intersecting each other. They both have a slope of 4. So see how my two lines are parallel to each other? So I started at 3 and I went up 4 over 1. So there's one line and there's the other line. I shaded the orange below. Where do I have to shade this other line though? Y is greater than. So I actually have to shade above or to the left of that second line. Will there be a feasible region? No. So because these are parallel lines and I shaded in opposite directions, this inequality actually has no solution. So none of the points in orange land will work in the second equation, and none of the points over here will work in the first equation. So you could actually have an inequality that has no solution. And I think that was it for that resource page. So there's one problem about the Freiburg Fair I wanted to show you about, like what are these, where do these come into play? Has everybody been to the Freiburg Fair? Anyone not been? Never? Never been? Oh, never been your whole life to the Freiburg Fair? Okay, well, he'll be back in October. So someone please take him to the Freiburg Fair in October. Okay. Yeah, he'll be back. He'll be back for the Freiburg Fair. So I want you to take him to the Freiburg Fair in October. Someone, because you haven't lived until you've at least seen an agricultural fair, right? So anyway, if you haven't been to the Freiburg Fair, we're just going to start to set up this problem, and then we can work on it next time too. But this is page 113. I'm flipping ahead to the Freiburg Fair introduction. How much money do you guys bring to the fair with you? A couple. My parents give me like a certain amount of money for like a whole week, and then I spend it like last year. Oh, you go multiple times? Yeah. Oh wow. Wow. I don't want. I mean, if you find something sweet at the fair, $10. $10. Oh, that's a lot of money. I am taking $50 here in my wallet. And are they still cash only? I think it might still. 113. Is there an ATM? But it's cash only still, right? Yeah. Okay, so it says you've already paid your admission cost and you have $50 in your wallet to enjoy. You plan to spend your money on rides, which cost $5 each for tickets. It probably is more than that. Is it $10 a ride? What would a ride cost you? Yeah, 113. Like $5 for one ride, do you think? Like $25 buys you like a string of tickets on a non-bracelet day. I don't know. I made this up. And food items, I said, cost $8 each on average. You buy an ice cream cone, or you buy a cotton candy or a French fry. Maybe it averages out to $8 per food item. They all are different. So I said, let's use these prices to answer the following questions. Okay, you have $50. What's the maximum number of rides that you could go on? Without getting food. This is how inequalities work. You could spend all your money and just do rides, right? So what's the maximum number of rides that we could go on? 10 rides, right? Right, because 10 times 5 is 50. Or 50 divided by 5 is 10. What about if I asked you, could you purchase 8 food items?